Hi, I'm Chris Nichols, Global Systems Engineering Lead for HyperFlex here at Cisco. And today we'd like to do a little bit of a chalk talk, or maybe considering the studio, a virtual chalk talk, around how exactly you can talk about HyperFlex if you only have a whiteboard in front of your customer. So there's a lot of different ways you can walk through a HyperFlex conversation, but what we'd like to focus on today is really around how is HyperFlex foundationally built upon UCS. What are some of the components that we're going to deal with HyperFlex? What are some of your scaling options? And how do some of these create large differentiations for HyperFlex and for you and your customers? So let's get started. So the first part of HyperFlex is the fact that it's built upon a UCS foundation. And I think it's really important just to walk through some of the advantages of UCS, because this was a compute platform that was introduced 8 years ago. And even today, it still has a lot of differentiation in the market that is even more relevant as we consider what are some of those advantages and how do they overlay on top of a hyperconverged conversation. So let's talk a little bit about what makes UCS UCS. And when you consider what UCS brought 8 years ago, it was the very first compute platform to marry compute and networking together in, for the first time, what was really an aggregated fashion. A couple of things that allow us to get some of these advancements are some of the parts and pieces of UCS. And the first one is the Fabric Interconnect, or FI. Now, the Fabric Interconnect looks suspiciously like a switch, but it's so much more than that. Because not only did it allow us a switch to connect all of the different types of compute constructs within UCS, it also gave us a management plane on top of that. And that management plane is something that we control via UCSM or UCS Manager. Now, the cool part about UCS is that it looked at management regardless of what type of form factor we had on the compute platform. So what this means is we could have blade servers or rack servers that were connected up to UCS. So I have my blade chassis up here. I have rack mounts down here. And the cabling for UCS was very, very unique to the industry, and it still is today. This is enabled by something that we call the VIC, or the Virtual Interface Card, which exists on each rack mount server or the chassis. So when we cable up all of these servers, you've only got really two connections coming out of each one of these either blade chassis or rack mount servers. So this gives you a lot of advantages as to how you cable it up, but the VIC's other purpose was really to look at abstracting the physical hardware away from how we wanted to do the server configuration. So let me explain a little bit about how that works. The VIC is a virtual interface card, and it really spans both HBAs and Ethernet connections. So what that allows me to do is basically look at the profile in UCS Manager and say, look, I want X number of NICs, I want X number of HBAs, I'm going to pull from these types of pools for my WWNs or my MAC addresses or whatnot. And also, because of that profile, it allows me to really look at the server like a fingerprint. So the service profile was something that we introduced with UCS Manager to say, given this server, maybe I'm going to look at this in just really kind of a fingerprinted approach, and based on what I want that server to look like from a configuration, from the CPU, the memory, the interface cards, the Ethernet cards, HBAs, whatnot, I'm going to build a profile around that configuration, and that profile can then be applied to each single server in my environment. So this is really, really valuable operationally because it allows me to really abstract the server configuration and look at that in a profile management portion on UCS. So imagine if you had 50 or 100 or 1,000 servers. As I plug more and more into my environment, I just then apply that profile. What was really cool about UCS is we could even take that a step further. So UCS was the foundation of a lot of our converged infrastructure approaches. And as we added storage into that mix, we added that into the Fabric Interconnect overall architecture. And this is something where we could just zone or cable storage up to those FIs. And all of the data for a specific server then lived on my SAN or my NAS appliance. Now, if you kind of take that a step further, what that means is for a given server, all of the data lives up here. It's not living locally on the server. So if we have a problem where we need to replace the server or address this from a failure scenario or anything like that, what we can do is basically just introduce that new hardware, assign it that same service profile, that fingerprint or the personality of the server that I just took out of service and replaced with net new hardware, and all of my data is instantly available because I can assign exactly the same personality to it. So this was something that really kind of got us a lot of different advantages in terms of stateless computing, scale-out computing, how I did failure scenarios and whatnot. But it also gave us a situation where that gave us the foundation from which a lot of the converged infrastructures started to grow upon the foundation of UCS. Now, it's really important to understand all of this stuff because as we layer on the HyperFlex data platform concentrations, this will be even more valuable for a customer as they look at different types of deployments for converged and hyperconverged. All right, now that we've laid the foundation with UCS, we're going to layer on top of that some of the specific HX data platform components that really exist on top of that UCS server. So at its core, HyperFlex exists on top of either a C220 series server or a C240 series server, which then give us either the HX220 or the HX240 nodes. So those nodes really only differ by how much capacity I want, how many drives I want, how far I want to expand that node. But at its core, those nodes give us CPU, they give us memory, and they give us some storage component. Now, on the hybrid nodes, this could be a combination of SSD for the caching layer and hard drives for the persistence layer. On the all-flash nodes, this is just all-flash. And we've even got some options around NVMe as that caching drive to get a lot of different types of ways that you can look at performance based on your application requirements. But let's assume that this is an all-flash node, so we're only looking at SSD for the persistence layer. Now, on top of that, we've got a couple of different things that we're going to layer on top that come pre-installed with every HX node you buy. The first is a hypervisor. And that hypervisor allows us, obviously, a lot of different things around standing up virtual machines. The other thing that we're going to add in conjunction with the hypervisor is a controller VM. Now, that controller VM is really the basis of our software-defined storage stack that we look at aggregating all of the storage components within each individual node to ultimately build out a clustered file system. But we don't really stop there with all of the specific nodes with the hypervisor and the controller VM. We also add in a really robust storage driver that we call the IOVisor. Now, the IOVisor's main purpose is really twofold. Number one, it gives us that storage driver, and number two, it abstracts all of the storage away from the VM that is sitting on that specific node. Now, that sounds a little bit counterintuitive, and we're going to get to exactly why that's important as we talk through all the different components in HyperFlex. But essentially, all of these components together give us the HX data platform. Now, that data platform exists on every single node, and as we add additional nodes, it's going to extend that platform. What this really means is you can have a large pool of resources that is CPU, that is memory, and that is storage. What's great about this is we can even look at a couple of different things independently as we start to scale. So, for example, if I've got an HX240 node and I only have, say, 6 or 7 drives in it, that node supports up to 23 persistence drives with HyperFlex. So that means if I just need additional storage in that node, I just add additional drives and just hot plug them into the front of the node. The HX data platform via the controller VM is going to pick up the fact that I now added additional storage, and it's just going to extend the file system across all of those drives in that specific node, which then extends my entire platform because all of these nodes are acting in parallel. So next, let's talk a little bit about some of the different things we can do with scaling. Okay, so what happens when we actually look at this at scale? Due to the magic of television, I've already built out my HyperFlex cluster here, and luckily we took a pretty good snapshot of the UCS picture we have. Obviously, it was an HX snap, happened really quick, and here we go, right? So this looks suspiciously similar to the UCS diagram because, again, HX is built on the foundation on UCS. But each one of these nodes now has all of the components that we just talked about earlier in terms of the hypervisor, the controller VM, the IOVisor, and so forth and so on. So at scale here, what we're going to do is basically pool all of those resources that become a much larger scaled out file system and a much larger resource pool for CPU, memory, and storage. But we don't really stop there. So what happens if we've got a bunch of VMs across this cluster? Well, first off, the VMs are going to attach to the HX Data Platform file system, and that exists across all of these nodes. So what that means is that even though a VM may live on one specific node, it has the ability to step out to multiple nodes for a lot of different reasons. So for example, if I do a write on one specific node, I'm going to mirror that write via replication factor on one or two additional nodes, depending on how I have my replication factor set. So not only does that give me the ability to look at multiple copies of that data for performance, it also gives me a resiliency component. And this is really important. So if that node goes down for whatever reason, maintenance, I lose a power supply, the node goes down via failure, or whatever the failure may be, this is something where that VM can either migrate if it's something that I know about ahead of time, or just stand up on another node via a reboot because of the fact that I'm running all of the standard HA components on the hypervisor. Now, when that happens and I instantiate that VM on a second node, it already has redundant copies of that data. So it is something that it can stand up very, very quickly, and it's got instant access to all of its data via those redundant copies. It's not something where we have to look at a RAID rebuild or anything like that. We've got the copies sitting there. We just simply reattach, and we're off and running. Now, let's talk a little bit about what happens when we need to scale this in a lot of different dimensions. Now, as we talked about, we can just simply add storage to each node, even a single drive at a time, if the capacity is my scaling concern. But that's not necessarily the only component that I need particularly to scale. So, just like any hyperconverged vendor, we can look at adding additional nodes into that cluster. So when we add that additional node, the great part is I've already got the hypervisor and the controller VM as part of that installation because it comes pre-installed on that node. I get the IO visor, I cable it up to my existing fabric interconnects. I look at applying that service profile automatically because we've already built all of the service profiles and the fingerprints for each one of these types of nodes via the installation process that happens when you install the cluster in the first place. So what that's going to do is allow me to build all of these service profiles automatically via the fabric interconnects and UCS manager as it relates to UCS, and basically say I just plugged in an HX220 node or an HX240 node and it's got this specific service profile. Let me just go through and assign that, and when I do that, I'm going to pick up all of those additional resources via the HyperFlex installer, and I'm going to extend the data platform across that new node. Now, that new node also has CPU, memory, and SSD. So not only do I allow myself to expand the file system, I also get a larger resource pool to which all of those VMs can now take advantage of. So this is something where instantly I'm going to look at a balancing act across all of those nodes so I can make sure that my VMs are balanced. I don't have any hotspots within the file system. I can look at self-healing. I can look at auto-balancing across that file system. There's a lot of advantages that we can do via the HyperFlex foundational principles that a lot of our competitors can't. But in terms of scaling, we don't even stop there. So we've looked at adding additional SSD. We've looked at adding additional nodes. We can add additional memory into these nodes. But because we're built on the foundation of UCS, we also have a lot of really cool stuff we can do in terms of scaling. So let's consider our existing UCS customer base. We've got 60,000 UCS customers out there. A lot of those customers may already have existing blade or rack mount servers in their environment. So if that customer is an existing UCS customer, let's say, for instance, this is a customer that has an existing blade chassis, they've got a bunch of B200s sitting out there, this is something we can also integrate into a HyperFlex conversation with the HyperFlex installer on a specific blade, and with that install comes an instantiation of the IO visor. Now, we talked earlier about the fact that the IO visor does a couple different things, and one of those things is to abstract all of the storage resources away from the node upon which it sits. This is where this becomes extremely valuable because even though I'm running only compute resources on the B200, this is something where I'm cabled into those same fabric interconnects. I can see all of the file system that's instantiated by the hyperconverged nodes and still use all of those storage resources for VMs that exist on the B200. So this allows me to extend that data platform even to UCS resources in my current environment. And this could be something that is a net new purchase, or it could be something that I already own within my environment. So it gives me a lot of flexibility. But the bottom line here is I don't necessarily have to scale within the confines and the constraints of a given converged node. I can also scale in a lot of different types of manners in terms of CPU and memory with the compute-only nodes. And again, this could be a blade, it could be a B200, B420, B460. It could also be rack mount servers, C220, C240, C460. Essentially, any type of UCS server can also be a compute-only resource cabled into the same pair of fabric interconnects. But let's say I've got a customer that says, look, I've got a couple of different types of use cases that require some different types of storage. We also have the ability, just like we had in converged stacks, to add in storage components into this. And this could be existing storage that I already own. It could be a net new purchase. But this gives us a lot of flexibility as to what exactly we need for that VM. So even though the VM may be hosted on HyperFlex, it can still attach to all of those storage resources cabled into those fabric interconnects. So the bottom line here is a lot of flexibility compared to other types of hyperconverged offerings. But the other thing that this allows us to do with especially customers that are looking at different ways of scaling with HyperFlex is a lot of different types of flexible options for scale that don't necessarily cost them a lot. So when I look at, say, a compute-only node with B200s or C-series rack mount servers or other types of B-series blades, this is something where we install the I/O visor, but we don't necessarily license all of the HX data platform components on that compute-only blade. So what this means is because we get such fantastic storage performance, we can look at different types of compute constructs and scale in a lot of different ways for customers to support application requirements with a mix of compute-only and hyperconverged nodes. What this means for you and your customers is the fact that I can look at my application and my VM requirements and really right-size that to the environment. So this is going to be something that gives you much better performance at a much lower cost and much more flexibility in scaling with all of the different types of things that we've talked about today. So I hope this was helpful for everybody. It gives you a really quick way to break down all of the advantages and all the different types of permutations for HyperFlex. But ultimately, this gives you a lot of flexibility as to how you can have that conversation with your customers, essentially using nothing but a whiteboard. So I hope this was helpful for everybody. Thanks a lot. Good luck and good selling.